Hey guys, this is the same handout, Unit 4 handout 9. It's page 2 now. It's the same thing, okay, but different numbers, different types of circuit, basically. If you want to, you can pause the video here and try to work this whole question out and then come back. I'm going to take it up, or I'm going to do it with you right now, okay, guys? And I'm going to do it kind of quickly, okay? Looks like the line voltage is 300. 300 divided by root 3. That's because it's Y, right? 173.2 volts. I'm taking the phase voltage and dividing it by the resistance of the load. Okay, so that's load 1. Okay, delta, so the voltages are the same. Ohm's law divided by 19. Got to be really careful on these, because if you make a mistake, your life is going to be really sad, right? And it's really easy to make a mistake. So go slow, take your time. No need to rush. Make sure you get it all correct. Okay, guys? Okay, Y load over here again, so Y, so the current's the same. Okay, guys, so we've calculated our 3 line currents. We're going to circle them here. Make sure we don't screw it up, okay? Because you want to use your line currents to calculate your total current. It'll be the phasor sum of the 3, all right, guys? So if I draw those 3 line currents over here on a little phasor diagram, okay, this is going to be IR every single time, 6.9. I mean, it is the resistive bank, right? And then IXL, the inductive bank, looks like it's 27, really long, all right? Then we're going to have the capacitors, which is going to be going up from there, right? IXC. And looks like I can calculate IX here, guys. Should be the difference between these two, right? So 27.35 minus 5.587. 21.76. Okay, guys, and then there's my total circuit current, right? I total, or I line alternator, same thing. And I'm going to calculate it right here, real quick, guys. It's going to be that squared plus 6.928 squared equals root equals, okay, 22.84 amps, and that's going to be right here, 22.84 amps, and it's going to be here too, also 22.84 amps. That's because, again, Y connected alternator, okay? Now, to calculate P, E line, I line root 3. VARS XL, E line, I line root 3. vars XC, E line, I line, root 3. Okay, that'll calculate all three of them. So let's do it one at a time. Those two there are P, right? 300 times 6.928 times root 3 because it's three phase. On tests, I've had students, they skip the root 3 here. They think this is single phase. Okay, don't do that. Make sure you're including the root 3. Make sure you're using line values. Make sure you're using root 3. And sometimes students say, can I use phase values and multiply by 3? Yes, you can, if you want to. It'll be fine. What am I doing here? 3, it's basically 3,600. Okay, watts. This one here, got to do this carefully, right? This is VARS XL 300 27.35 times root 3. And yes, you should circle them when you do it. Make sure you don't screw it up, right? Easy to do. 300 times 27.35 times root 3. 14,211 bars. Okay. Now we'll do the last one, or at least the last, load bank here. 300. It's going to be that one and that one, right? $300 times 5.587 times root 3. 2903 VARS. All right, guys. So far, so good. VA. When I calculate VA, guys, I go E line, 300, I line, 22.84 times root 3. So this is going to be 300 times 22.84 times root 3. I'm just calculating the VA, the load, using E line total, I line total, root 3. So 300 times 22.84 times root 3. Looks like the VA for this thing is 11,868. VA. And yes, if you drew phasers, those three phasers, you should still get the same number. Won't make any difference at all. Okay. I'm going to change this one up a bit. I'm going to calculate the phase angle. I'll use this phasor diagram here. The opposite over adjacent, inverse tan. Okay. And then I'll hit cos for the power factor. Lots of different ways to do it, so I'll show you a different way here, okay? So I'm going to go opposite, 21.76, divided by 8 adjacent, 6.928, equals shift tan, okay? So opposite over adjacent, inverse tan. Looks like this is 72.3, 4 degrees. And then I'm going to hit cos and hit equals. Looks like it's 0.30, 4. Is the phase, is the power factor, okay? And again, I could have gone P over VA. I would have got my power factor that way as well. Leading or lagging, guys. Here's the voltage. There's the current. This thing is lagging, okay? So, a bunch of different ways to do it. Just for fun, since we got a bit of time, I'm going to recalculate my power factor, P over VA. So it should have been 3,600 divided by 11,868. Okay, guys, and look, it's 0.30, 3. All right, guys. So then I could hit shift cos and hit. I'll get 72. All right, guys. So a lot of different ways to do it. You need to take your time. You need to be accurate. Okay, guys. But if you take your time and are accurate, you can get 100% on this, no problem at all. Make sure you include root 3s in your calculations. All right, guys? And your homework is going to be Unit 4 Handout 9. Oh, what is it exactly? Unit 4 Handout 9. Unit 4 handout 10. Sorry about that, guys. And anyway, if that's not right, check Econestoga. I think it's right, though.